Again, I'll reiterate, right? All I'm looking at here today is I'm introducing something called the sine rule. And what the sine rule describes, it describes a relationship between the opposite sides, the pair of opposite sides and angles, right? Lucas, just remind us again, what did we find, right? What did we find when I found these fractions here? What did they all equal 2? They all equaled the same thing. They all equaled 2. And I've just generalized it here. I've said that a over sine a is equal to b over sine b equals to c over sine c. What this tells you, year 10, is that it actually doesn't matter which sides and angles that you get, okay? You can always use this idea of a sine rule to create an equation to find an unknown side. Just keep coming back to this goal, right? The goal in trigonometry here is that we're trying to find these values, these unknown values. And the steps that we always use to do that is that we want to use our information to create an equation. And I could have written like steps here to say, oh, label sides, use this formula. But I just want you to get ingrained that anytime we're looking at trigonometry in this context, all I want to do is use this to find the unknown value. Now, before I jump straight into this question here, without using the sine rule, is there a way I could solve this question?
Yes.
Yeah, well, think back to the question that you just solved up on the board there, right? We could use our normal tan ratio, couldn't we, right? If I chose 48 degrees here, right, this would be the opposite and this would be adjacent, and you can just use the normal way here, right? This is a right angle case, and I want to show you that it will still work if we use the sine rule. But the power of the sine rule is that it will work for any case. It doesn't have to be right angle. So let me show you how I'd set up a sine rule question for this one. What I would say is, okay, I'm looking for the length A, I know that. And so I say A over sine of the opposite angle. So I say this is my side here, that's the opposite angle. That would be sine 48. That would be equal to, and then I remember, I just look at the format that I've got here. I've got another one of the sides that I know. In this case, I know I've got 15. And I say, okay, what's its opposite angle? Well, that's 42 degrees. That's equal to sine of 42.
So why can't we just do the other one?
We can, but we can't use it for the non-right angle triangles.
But then why wouldn't we just use it for the
Well, why don't you just try, and I'm just showing you that it actually works for both of them. I'm showing you that it actually works for both of them. Again, right, think about this. The goal is to always find the unknown value here, right? Joel, can you help me out with this next one? If I'm trying to find the unknown value A, what operation would I need to use so I can get A by itself? Good, right? Remember, always think about opposite operations when you've got these equations here, right? The opposite of division is multiplication. I want to get rid of this fraction here. So I'll multiply both sides by sine of 48. So that would be 15 over sine 42 multiplied by sine 48. And then all you need to do is just put that into your calculator. Okay. Has anyone got a value for me that I've got? 16.6. Awesome. Cool. Alright, get that down for me, year 10. Sorry, year 10, before I go on, Jade asked a really good question. She asked, what about that C? What about like the third pair, right? The third pair of the angle and the side. Yeah, right. So all this is saying is, it doesn't matter which pairs we have, we can always use this rule here. Right? That's why they've set it up like this. It doesn't matter that we don't have this third one. We don't need it because the goal is just to find A. Let me just confirm again with you with doing a second one together, and then let you go on by yourself, right? Yep.
Tell me, what's the difference between using this rule for a right angle triangle and not a right?
There is no difference, but for this one we can't use the normal ratios. We have to use the sine rule for this next one here. Okay. So again, I'm just going to do this setup, right? I've got my side length here, A, and I look to its opposite angle. That's sine of 28. Abby, can you help out with the next one? If I have a side length of 13 here, that's the other side that I'm given, what's its opposite angle that I've got? Sine 63, well done, right? Again, nothing too difficult. All I'm doing here is I'm remembering I want to find an unknown value, in this case it's A, and I can use this sine rule relationship that the side lengths and its opposite angles will be equal to any other side length and its opposite angle when I set up this fraction in this way. And then again, I just think about opposite operations. I say A would be equal to 13 over sine 63 multiplied by sine 28. And then just chuck that into your calculator for me. Just for now. If you guys finish all of the examples on the board, here's the next sheet for you guys.